So now we're going to solve this by substituting, because we already the first equation is already solved for one variable. So now you can use -2 instead of y. So now you rewrite the second equation and you're going to plug in y. What's the y value here? What's the y? It is -2. It is y is -2. So which means that you can use -2 instead of y. So now let's just simplify this. Use the PEMDAS strategy. So let's just go. For x, what is -3 times by -2? -3, -2. That's positive 6, 18. So -6, -6, two-step equation. So now this will be gone. For x is equal to 12. X is equal to 3. So now x is equal to 3. So the solution of system, we just find just 50% of the answer, 3. And now you need to find y by plugging this 3 into one of the equation, right? So now I'm going to plug into the second, because the first one, it doesn't have x. So now 3y, 18. So x should be 3, because I just found it, 3. So now what is 4 times by 3? That's 12 minus 3y is equal to 18. The reason why I'm choosing the second one, because I want you to practice simplifying and solving, two-step equations. So now let's just check the sign of 12. It's plus, right? So now you have to undo this added by 12. Don't add it because of like this negative sign, minus sign after 12, like sign after a number, it doesn't matter. So you always check the front part. This will be gone. Now you need to bring negative. And what's 18 minus 12? It's positive 6. So divided by -3, divided by -3. Y is equal to -2. So now -2 is right here. So the answer is C. We're going to talk about like the systems with infinitely many solutions or no solution. We already know how to find the answers for this, because when we graph it, if there's no solution, which means when two lines are parallel, there is no solution. And infinitely many solution, if two lines are exactly same, let's say this blue line and the red line, you graph it, but it turns out those are exactly same. It means that there are a lot of points on the line, on both lines, makes both equations true. So it has infinitely many solutions. So A. So now we're going to find a solution by substituting. So now the equation is solved for x, which means you can use this guy instead of x. So now let's just plug in -2y plus 4 plus 7y is equal to 14. So let's simplify this. So 3.5 times -2, -7y, and 3.5 times by 4, it's 14. It might take some time for you, but it's okay. Take your time and show your work on the graph. And let's just combine the like terms. So now we have like terms of -7y and 7y. So what's -7y plus 7y? It is actually 0. So it means that those are canceled out. So now what's left over? We have 14 is equal to 14. Is it true statement or a false statement? True or false? It is always true, which means there's a lot of order pairs, which makes this system true. So it means that there are infinitely many solutions. So when you like when you get to the last line and then there's no variables at all, then you can say, and if the statement is true, then you may say, oh, you have to say there are infinitely many solutions. So let's look at the next one. Now I'm going to use 3x minus 11 instead of y. So I'm going to substitute 3x minus 11 for y, and I'm going to just leave the rest of them exactly same. So now let's just combine the like terms. We have 3x and negative 3x. Also, 3x minus 3x is equal to 0. So this will be gone. And now we only have negative 11 and negative 13. What do you think? Is it true or false? Negative 11 is not equal to negative 13. So it turns out, oh, it's false, which means there's no order pairs, which makes this systems true at all. So there's no solutions. So once you get to the false statement, then there's no answer. There's no solution which satisfy this both the equation true at the same time. And you may think that, oh, the lines, if I graph it, the line should be parallel. I need you to connect between this graphing and substituting, okay? Because both are talking about the same situation. I need you to try the next question by yourself on your paper and try to find a solution and try to think if there's only one solution and if there's infinitely many solutions or no solution. So now you have 3x minus 5. So you can use this guy instead of y. So I'm going to plug into here. So 6x and 2. And it was y, but I'm going to use 3x minus 5 because it says they are equal, plus 10. So the next step is you need to simplify. If you have a grouping symbol, you have to do distributive property. So now 6x minus what? 2 times by negative 5, negative 5, negative 10. And we have 6x on the left side. And we have a like terms on the right side, which is negative 10 and positive 10. So it's going to be 0. And we only have 6x is equal to 6x. Oh, they're exactly the same, but now you have to undo one of the variables. So I'm going to do minus 6x minus 6x. 0 is equal to 0. Is it true or false? It is true statement, right? Because 0 is always equal to 0. So now we can say there's a lot of order pairs, which makes this equation true, which means there's infinitely many solutions.